Let's talk about the waiters that we have inside selenium.support.ui namespace. The very first waiter is the FluentWait. Now FluentWait takes on the condition on which you want to wait, and you can specify the amount of time you have to wait for, and you can also specify that after how many seconds or milliseconds you want the waiter to check for for a particular condition. The condition is whatever you want to check on the web page. So let's take an example here. Our example talks about a small timer. This is the timer page. It's actually a counter which a decreasing counter which decreases from 40 to 0, and once it reaches 0, it displays a text buzz buzz. So let me show you how it works. So once the page loads, it starts counting, right? So once 0 reaches, after 0 it shows buzz buzz. Now I want to create a test where I want to load the page and then I want to wait till this element shows buzz buzz, the text buzz buzz. Now this can be achieved using the FluentWait, and this will be the example all through the different waits that we will talk about right now. So I have created a FluentWaiter. Now this FluentWait is the syntactically you have to write it like this. Now we have chosen a web element here because this is a web element. Where is that? This is a web element, and we want to wait on a property of a web element. So I have created a FluentWait on a web element, and I have passed the element. Now this is the element that that the counter represents. It has an ID of a countdown. Now I can specify the timeout and the polling every parameters of the waiter. Now with timeout means how many seconds or milliseconds or whatever time unit you want to specify. Whatever time unit, it could be seconds, milliseconds, or even an hour. So this will tell, with timeout will tell the waiter that you have to wait for X number of time units before you expire. So in our case it's time unit dot seconds, and we have set it to 600 seconds. So this waiter will wait for 600 seconds before it times out. Now polling every is an interesting concept in which I will tell my waiter that I want you to check for the condition to be true every 500 milliseconds. Now this is how you create a waiter. You have other options also. For example, we can use wait.ignoring. This is another method available in the FluentWait, and we can tell it to ignore any exception of the type that you have mentioned inside it. So right now I have said I want you to ignore all the exceptions which are of type no such element exception. So what will happen is that while polling for the required condition, if it finds if this exception is raised, it will ignore it. So this is how you configure your FluentWait. Now you have to write down the condition. What is the condition that you have to wait on? So you have to create a method which you have to create a function which checks for the condition. You can do it in two ways. The first one is by creating an I function, or you can say it as function ft. Now this is a f and t are generics, which are the runtime values that this function will receive, and then we have we can create a predicate of type f. So these are the two ways you can create a condition. Now the important part of a function, the important role of a function and a predicate is to assert a condition, to verify whether the condition is true or not. And all it does is that based on whether the condition is true or not, it returns a true or a false or any element of type t. And in case of predicate, it always has to return a boolean value, either a true or a false. Now we will see how it is done. So right now we will create a function which will accept an input parameter of web element and which will return a value bool. And I will name the function as f, and I will create the function. Now this is the syntax of creating a function. Now inside it, this is the opening braces and this is the ending braces. Inside it, all you have to do is you have to override the apply method. Now this method is has to be implemented because we are implementing I function interface. Now this method is where all your logic, all your wait logic will happen. So as I said, we have to wait on the element on our counter here. Where is that? On our counter here till it shows buzz buzz. So what I have done with the element that I have passed earlier, I will get the text value of it and I will check whether it is buzz buzz or not. If it's not buzz buzz, which is here, if it is not buzz buzz, I will copy the value inside a string variable and I will check whether the value is equal to blank and the integer value is divisible by 2. So this is just an extra logic that I have put. So you can remove this logic. Actually, let's remove this logic and let us see how it works. So what I want to do here is that if the value is not buzz buzz, I want to just print it out. I want to print it out on the console and say that the value of element is this and return false. So if I return false, my waiter will again poll for the condition to become true. And if in case the element value comes out to be buzz buzz, I want to bail out from the function, and before coming out I want to print hooray, found the element, and return true. So once I return true, the function will exit and the waiter will stop. So let us use this function. So all I have to do is wait dot until. As you can see, until has two overloads. The first one is function, it accepts a function. Second one is it accepts a predicate. Let's take an example of function first, and the name of our function is f. Now pay close attention to what will happen. So I've launched the test. It should open the timer object, the page which hosts the timer object, and let's see how it works. Sorry for keep you waiting for 40 seconds because it's a very important concept and I hope you get through it. So this function, I function interface, it's a very important Java concept. You can learn about it on the Java documentation, and I think to use all the waiters in the UI namespace, you have to go through predicates and I functions before you can actually use them. So I've run my test and should open the browser anytime. I hope it opens it. Sometimes it gets really slow. I don't know why. And the browser has opened in the background. Well, I think I did something wrong here. Yeah, so what I did wrong is that we have a different page. I have to go to this page, and from here I want to find the element. Let's try to run it again. I've run it again. So the functions I function and the predicate, as mentioned here, they are just a way to assert a condition, just a way to verify whether the condition is true or not. All it does, it creates a piece of code which goes in line with your waiter. That means the waiter executes your code as it is. So this is the page that comes up. As you can see, that will load the counter n .html, and as you can see, now I am inside the wait logic. As you can see, it's printing value of the element, right? So if you look at the I function code, so it says that if the element's text value is not buzz, I want you to print it out, and I want to return false. So till the time it returns false, the waiter will keep on executing the same piece of code. As the value here becomes buzz, it will return true, and that is when the waiter will stop. So as you can see on the page, it showed buzz, and here it checked for this condition and it found it to be true. It came out of it and it returned true, and as soon as it returned true, it printed the required text and it came out of the wait. Now this is how a FluentWait is implemented. Now you can change this particular text to suit any of your needs. For example, I would say that I want instead of buzz text, I want it to show me a value 20. So I want to exit once it shows me a value 20, and I will say value 20 appeared. Now if I run the test again, now instead of waiting till the complete timer has exhausted, it will wait till the timer shows the value 20. Now this will become very interesting, and right here between in the apply method, you can write any piece of logic that you want. The condition is that it should return a boolean. You can change it to return any object of your choice, but right now we are taking an example of boolean. So let me just close this browser, the earlier browser. Now this is opened up. Now you will see how the waiter will work. So it will again start counting, and it will our test code will again start printing, and as you can see, it will keep on printing till the time we get 20. So it is trying to check the condition every 500 milliseconds. That's why. So you can see that value 20 appeared and it came out of the waiter. Now it came out of the waiter, and this is how we wait for a particular property to appear before exiting the wait. Similarly, you can implement this exactly using a predicate. Now I have created a small predicate earlier. This is the static predicate, and it again uses a web element. Now the main difference between predicate and a function is that predicate always expects a return value to be bool, but a function can have any return value. So while writing a function, this is the return value specification. Right now we have chosen boolean, but it could be anything else. So we can create a predicate and we can have like something similar to it, and let's say in our case I want so in this particular case, what it's trying to do is it's trying to check whether the value is blank and the value is divisible by 3. If it is, then it will come inside it and it will return false. So we can run the same test again, and we can, instead of f, we can just say predicate, because predicate is the name of the predicate that we have created. So this is the predicate that we have created. Now predicate is also a way to assert your condition. If we run this, you will see that it should only show only the numbers which are divisible by 3. Now while it is running, let's move on to the next wait, which is WebDriverWait. Now WebDriverWait is a subclass of FluentWait. So it means that WebDriverWait exactly works like a FluentWait, but this only works for WebDrivers. I will explain to you how. So let me just look at the example. Again, the page has loaded, the counter starts, and once the counter starts, the waiter works. Now I think it has already returned from the function, that's why it didn't print anything. So yeah, it shouldn't print anything because it will return out of the function as soon as the condition is not met. Let us rerun the test. This time I have put a get text when it is returning, so we'll see when it returns. So we are running our test. Initially you may find predicate and function to be a very tough concept, but once you get along with the code, it should be a piece of cake. So you will see that it loads, and once it loads the timer, we would see that our waiter might have returned. Yeah, so it returned at the value 40. So right now, so it returned true, that's why the waiter stopped. Now you can modify this predicate to meet your other conditions also, for example something similar to this, and if you don't want to do much work, all you can do is just copy it here like this inside the apply element. Oh sorry, I think I didn't copy it correctly. Apply method, yeah. Okay, so there you go. Now this predicate will also perform exactly the same steps which the function performed earlier. So as we were talking about the other waiters, WebDriver expected condition UI sleeper and browser launcher dot sleeper. So WebDriverWait is again a sophisticated wait which only works with the WebDriver. So what it means is that let us run the test first. It's actually running, so let it complete first. There you go, it launches the timer, and you will see that I will start counting again. Look, so it has again started waiting till the value of the element comes out to be 20, and it will exit from the wait once the value is 20, as you can see right here. Yeah, so the value 20 appeared and it came out of it. Now you can see that every element, the value of element is printed twice. The reason is that we have set the polling every to 500 milliseconds, and the timer is changing value every second. So in every second our waiter will poll for the element twice because it's doing it in 500 milliseconds. Now let's talk about our WebDriverWait. Let's create one WebDriverWait. Before that, let me just cut this thing out so that, yeah, so there you go, WebDriverWait. And again, it is always created on equals to WebDriverWait. It's always created on WebDriver. I think I'm doing it syntactically wrong somewhere. Let me just copy the previous piece of code in the interest of time. There you go. So WebDriverWait. Now this is how you create a WebDriver wait. You create a WebDriver wait with a WebDriver and the amount of seconds that you want to wait for. Now again, WebDriver wait, as it's a subclass of FluentWait, it gives you two methods with timeout and polling every, which has exactly same reference which we had earlier. Now we can create a wait a function for our WebDriver wait, but this time while creating a function we have to be sure that the function takes the first argument as WebDriver, else this function won't work for a WebDriver wait. Now WebDriverWait is just a specialization of FluentWait. Now with the same logic I have created that till the time the text is equal to buzz buzz, I will display no buzz buzz, what instead text. That means it will print the value, and else it will, once the buzz buzz text appears, it will print buzz buzz found, hooray. And we can run this test again. Look at the code. It's exactly same. It's exactly the same way we created a function earlier. Let me cancel the first attempt, and this time, yeah, this time it will wait for 30 seconds. Let us modify it. Let us wait for 20 seconds, the value 20 to appear in the counter, so that it's not so that we save some time. So there you go, the test starts running. There you go, the counter will appear 39, 38, and as you can see, like the earlier test, it's now printing the value but with some different text here. But pay attention to these values, which are exactly the same, and as soon as 20 comes up, it will bail out of the function and it will return true, and it will say buzz buzz found, hooray. So we didn't change it to 20, that's why it printed this. And this is how we create a WebDriver wait. So if you have understood FluentWait, WebDriver wait is just a specialization of FluentWait. Now let's talk about the expected conditions. Now expected condition again returns a predicate. So let's say this is the function you have returned for your WebDriver wait. With expected condition you don't have to write so much. Let me show you how. So all you have to do is WebDriverWait dot until dot, no, it's not WebDriverWait, it's WebWait dot until, and all I have to do is I have to say expected condition. So as you can see, it's function super WebDriver and v. So expected condition dot class expected conditions dot, where is dot, and I can say that till the text of the element. There are lots and lots of methods available, so if we go by them one by one, it will take a lot of time, but let me explain to you a couple of them. Alert is present. So this function helps you to make your waiter, your WebDriver waiter, to wait till a particular alert is present, element to be clickable. So this particular method will let your waiter wait till a particular element is clickable. Similarly, the names are very descriptive. You can go through them and you will understand what they are trying to do. And what exactly we are looking for is text to be present by the element, present in the element. So I want to say I want a text. So the locator is countdown by and I want the text to be buzz 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 buzz. Okay, so the locator is actually element, so all I have to do is pass the element, and so what it will do is it will wait until the element, the text value of the element becomes buzz buzz. Instead of text to be present in element, we can look for text to be present. Yeah, this is the one. Now if I run this test, so just to confirm, when it returns out of the waiter, when it returns out of this statement, I will write a system.print system.out command. I will print something on the console. Well, these print commands are my favorite because I am out of waiter. These are my favorite because it helps me understand the code flow. It teaches me about how the code path, how the code has been executed. So if I do this, so I've run the test, and you will see that this time it will wait for whole 40 seconds, because after 40 seconds buzz buzz will appear, and then after that it will come out of WebWait, it will come out of the WebDriverWait, and it will print I am out of waiter statement. Look, here we are, and it will start counting. Now you won't see anything in the console because as it has a this expected conditions make your code look very clean, but it has a drawback that you cannot customize these expected conditions. So it has to be one of the expected conditions which Selenium is providing. If you want to modify, you cannot do anything with that, even the logging part. So everything comes as a package. But with the, so as you can see, we have reached 3, 2, 1, and as soon as the buzz word appeared, I am out of waiter appeared here. So the drawback is that it doesn't give you customization, but yes, it makes your code very clean, and it's a one-line statement as compared to writing a predicate or a function. That way it's really good. Now let's move on to the next waiter command, which is the UI sleeper and the browser launcher sleeper. Now I would not recommend you to use these sleeper commands because these are static sleeps. That means it makes your, okay, so before explaining this, let me show you in a diagram. So we talked about all the weights available in the .ui namespace. So the FluentWait and the derivatives of FluentWait, which is a WebDriverWait, and the expected condition weight, these three weights. So these are derivatives of FluentWait only. It's actually not a derivative, but this expected condition actually returns a function, and this function is used by WebDriverWait to perform the wait. So this is how they are linked. In all these cases, what happens is that during the sleep time, the wait time, WebDriver is actively, not continuously, but actively looking for the element, right? So within whatever time frame that you have set, WebDriver will constantly poll the web page to verify whether the condition is true or not. Once the condition is true, it will bail out, and we will move on to the next statement. Now the sleeper class, that is the next waiter, it is a static wait, because what it tells is the thread to sleep for the amount of time you specified. Now once you use this thread.sleep, all the actions will be paused on the thread. Thread will be paused, right? Nothing will happen on the thread, and you have to wait for the time the sleeper wait has been applied for. There would be no intelligent logic to come out of the wait like we did in FluentWait. Now this is the main difference between a sleeper wait. Now well, it's quite easy actually. It's nothing but sleeper not, well, you know what, let's do one thing. As I have explained to you other waits, I want you to learn about the UI sleeper and the browser launcher.sleeper waits through the Java docs. It will help you understand Java docs and how to read them. But in a nutshell, all these waits, what they do is thread.sleep, and whatever time frame that you have given, it will just sleep for this many seconds or minutes. Now this is not an intelligent wait. It will wait for 8,000 milliseconds for sure, even if the whatever condition, the wait condition you have specified meets. So that's why nobody uses them. I hope you are able to understand waits now. You are able to I hope you will be able to program your waits more efficiently and with the knowledge of what wait to use at what time. Thank you for watching the video.